Now we're moving into Chapter 8 where we do accounting for long-term assets. Long-term means anything longer than an operating cycle, which is typically 1 year. So we're looking first at problem 8, 1B. And in this one, we have a company that negotiated a lump sum purchase of several assets from a contractor who is relocating. The purchase was completed on January 1st with a total cash price of $1.8 million. And there was a building, land improvements, and 5 trucks. So in order to depreciate these, because they all have different useful lives, we have to allocate this $1.8 million to the assets. And so if we look at the different assets, the building, the land improvements, and the trucks, if we add all of that up and it happens to equal 1.8 million, then it's real easy. But typically that's not what happens. So the first one is the building, 890,000. The land, is 427,200. The land improvements, 249,200, and the 5 trucks, 213,600. And so where they get these amounts is from an appraiser. Typically, you'll have to have an independent party come in for an appraisal. And so we see that the actual purchase price of all of those equals $1,780,000. So what we have to do is allocate this 1.8 to these 4 assets. So to do that, we take the percentage of the whole. So the building, 890,000, divided by the total purchase price. Now in Excel, if you, well, it doesn't work that way in a Mac apparently, but in Excel, if you will put a $ in front of the row reference and column reference and row reference, then that's what's called an absolute value. Now what will happen when I fill this down, that absolute value won't change, but the relative value will. So those of you that use Excel often probably already know this, but that's how you can use cell references in Excel to fill down formulas. Okay, so then what we do is we take the purchase price, the 1.8, and we make that absolute, and we multiply that by the percentage allocated to that asset. Keep that relative because when we fill down, we want that to change. And then we pull that down, and then if we sum this, we should get the 1.8 million. So what we've done is we've taken the 1.8 million and allocated half of it to the building, 24% to the land, 14% to land improvements, and 12% to the trucks. Now we do that because each of these assets has a different useful life, and to depreciate that, we have to have those separated. So to do the journal entry for that, on January 1, we have a building, which is a long-term asset. We have land improvements, and we have trucks. And we paid for all of that with cash. So the building goes on the books at $900,000, the land at $432,000, the land improvements $252,000, and the trucks $216,000, and cash went out of $1.8 million. So that's the journal entry for the lump sum purchase. Then the next thing they ask us to do is to compute the depreciation for year 2015 on the building using straight line method, assuming a 12-year life and $120,000 salvage value. So to calculate depreciation, we take the cost of the building, the book value, and we subtract the salvage value, which is $120,000. And then we divide that, we're doing straight line, so we just simply divide that by the number of years in its life, which is 12, and we come up with $65,000. So that is the annual depreciation on the building. So for 12 years, you'll depreciate $65,000, and at the end of 12 years, you'll have $120,000 of the book value or cost of the building still left because that's the salvage value, meaning that's what it's worth at the end of its life. Then it asks us to calculate the depreciation on the land improvements, assuming a 10-year life and double declining balance depreciation. So a different method here. For double declining, you don't take into account the salvage value, which there is no salvage value on this one anyway. And so to do double, we take 100% and we divide by 10 years and we multiply by 2 because it's double. And so we have a 20% depreciation rate. So to calculate that, this is part 3. To calculate that, then we take the 252, which is the cost of the land improvements, and we multiply that by 20%, and that gives us $50,400, which is the depreciation on the land improvements using the double declining method. Okay, that's problem 8.1b. The next one we're going to look at is 8.2b. And I'm on the same page, page 382. And in this problem, we have a company that installed a new machine costing $324,000. The life of the machine is 5 years. Salvage value is $30,000, meaning what it will be at the end of its life. And we need that information to calculate depreciation, but then there's other ways to calculate depreciation based on usage. And so we also know that units that it will produce over its life is 1,470,000. And then it gives us actual production in the next few years so that we can calculate depreciation. And so in this one, they ask us to complete the table. And we have year, we have straight line, we have units of production, and we have double declining balance. So those are the different methods that we can use. Now you do one or the other, you don't do all. And so this company, what we want to do is look at the difference in depreciation each year using these different methods. And so in the first year, year 1, and we know we're going to have 5 years. We can go ahead and put that on there. Straight line is the same every year. It's your cost minus your salvage value divided by the number of years. So it's $58,800 every year. And if I make those absolute, you can hit your F4 key to make all of those absolute. Then I can fill that down and it'll show me my straight line depreciation for every year. Units of production, the way that works, and to follow along with our formulas just so you can kind of see this. If I come down here and put my units of production for each year, which is given to me in the problem. So year 1 was 355,600, year 2, 320,400, year 3, 317,000, year 4, 343,600, and year 5, 138,500. To do units of production, what we do is, first of all, we have to figure out what the cost is per unit. So we take our purchase price minus our salvage value, because we know we're going to have that left over at the end of the life. I'm going to go ahead and make these absolute by hitting my F4 key. And then we divide that by the number of units we're going to produce over the life of the asset, and I'll go ahead and make that absolute as well. And then we multiply that by the number of units produced that year. So for this year, the depreciation would be 71,120. And then if I did my formula correctly, I can fill that down and I can determine how much depreciation I will take each year. Now, with units of production, your estimate may be off a little bit. And so what we want to do in that last year is make sure we didn't go over what we should have, and we did. And so in this last year, what you can do is a different formula. You take your cost minus your salvage value to get your depreciable basis, and then subtract from that the previous year's depreciation. And you can do it this way, or you can do a sum, whatever works easiest, and know that that's how much you depreciate the last year. So you can make sure that this total depreciation right here is not more than the depreciable basis. Okay, double declining balance method. To do this one, first of all, we want to come over here, and it's 100% divided by 5 years, times 2, and that's going to give us 40%. So that's our amount that we'll use. And I'm actually going to change this a little bit so I can use my cell reference. There we go, 40%. And so to do that, we take our beginning book value. Now for this one, we don't subtract the salvage value, and you'll see how we account for that at the end of the problem. But we take our book value. Book value is your cost minus your depreciation. And in year 1, there is no accumulated depreciation. So we simply take that times our 40%, and that gives us our depreciation for the first year. And then, let me move this. You have to keep up with your book value when you're using the double declining method. And so I'm going to go ahead and put book value over here. Book value is your cost minus your accumulated depreciation. So at the end of this year, your book value is the cost, $324, minus the depreciation. So the book value at the end of year 1 is $194,400. So the depreciation for year 2 is your book value times your percentage. And then over here, we would want to take our book value minus our depreciation. So $116,600 is our book value. And I could use cell references and fill down, but kind of want you to see how this works. So you see what I'm doing on the book value every year is I'm just simply subtracting the depreciation that we took the year before. And then I'm taking that book value times the rate of 40% to determine what the annual depreciation is. Now, again, you want to make sure that your book value doesn't go below the depreciation that you want to take. And so in year 5, you can do a couple of different things here, but probably what I would do is I would take in my last year, my cost minus my salvage value, and then subtract from that the depreciation that I've taken so far. And then that will be the depreciation for the last year. And you can now hear my dog.